Hello, everyone, and welcome to today's session, which is Assessing Deeper Understanding by Engaging in Authentic Assessment. We'll get started in just a moment. But to start, there are a couple of housekeeping items. There will be a few minutes at the end for questions, so feel free to leave those in the chat window and we'll circle back to as many of them as we can in the end. Also, if you'd like to learn more about digital ed or our platform, Möbius, you can find our booth in the exhibit hall or follow the link in the chat. I'm going to just get started now here. So today's topic is on assessing deeper understanding by engaging in authentic assessment. So in today's session, I'm going to talk about a couple of things. The first is just what do we mean by authentic assessment and how do we assess deeper understanding? But then also, I want to talk about, what type of questions can you ask if you have the right platform that gets at some of the higher order Bloom's taxonomy. When I talk about authentic assessment, really what I mean is assessments that are worthwhile, significant, and meaningful. Right? They test the student's skills and knowledge in realistic situations. So we're not just making up a question just to ask the student to do some procedure that we've learned in class. We want to actually show them how is it going to be used in a realistic situation. And really, the goal is to get them to apply their knowledge across multiple skills. So not just necessarily rote learning. And we want to really get to the ability to do sort of higher order assessments. And by that, what I mean is let's look at Bloom's taxonomy. So Bloom's taxonomy, this particular image came from the University of Florida, talks about the cognitive domain. So starting at the remembering, being able to just recite facts that you've learned and recite them back. Going into understanding, meaning you understood what you've told and you're able to then apply it. And applying it in the existing situation, but also then being able to apply it in a similar but a new situation. Finally, then taking it and analyzing something that you've learned and identifying how the different things relate to each other and how they relate to other elements that the student might know. Moving into evaluating and then into creating. Those are at the top level of the higher order thinking skills. Now, if we think about this in terms of math, what does that mean? So really, at the remembering side, you have the list or define or identify. So it's those elements of things that can they recall what they have learned. Moving into understanding, then they're asked to maybe estimate or discuss or summarize. And then apply, which means sort of being able to calculate something to show or to solve. And sometimes, you can ask questions at different levels. So you can ask the same question, but it's going to lead to a higher order thinking. When you get into the analyzing, it's more, how do you separate things? How do you arrange things? Can you classify? So if you have looked at some elements and you've figured something out about them, can you now classify them and explain what you know? And then into the evaluation, being able to sort of explain, discriminate, sort of assess what you've learned, right? So examine some information and make judgments based on that. And then at the top level, answering more what if type questions, or how do you formulate something or generalize from what you've already learned into a new situation. This is the cognitive domain. Now, in about 2001, Anderson and Krathwohl also talked about, it's not just the cognitive domain, but there's also this knowledge domain. So within the cognitive domain, you're moving up the pyramid, but at the same time, there's another scale, the knowledge of what the student is understanding, going from factual and then conceptual all the way up to metacognitive. And so I found another nice slide here from Iowa State University where they've combined those two, the cognitive dimension with the knowledge dimension. And so you can see rather than just a straight pyramid, we actually have this sort of stepped stepped idea of higher order thinking. And so you want to get the students from the sort of remember and factual side up towards the create and metacognitive side. So there are lots of different paths that you can take students on, but really what you want to look at is how do we start to assess students at a higher level? And when I think about how to do that, there are a couple of things that you look at. Just alternative assessments. How can we use assessment in a different way to get at these additional pieces of knowledge that a student has or doesn't have? So when I think about the first thing to do is really, how do you ask questions in different ways so that you can assess those different levels of understanding and really avoid plug and play? One of the things that we've found in the last year and a half is that if you ask a student a question, if they're remote and they have access to their material, they have access to their calculator, they have access to the internet, they have access to their phone, they're able to plug it in and search for it and find an answer. So what we need to do is we need to think of other ways of asking questions that actually makes them think beyond just plugging that in and getting an answer. And so one of the key things that Möbius has to help with this is a wide variety of question types, from your sort of very basic multiple choice and numeric questions, but up through maple graded questions and even algorithmic and adaptive questions, so that you actually have a choice when it comes to asking students questions, and you can really start to get at, do they actually understand, or what do they understand? The other thing that we can look at is, how can you use the features of technology in different ways? So a traditional homework assignment, there are 10 questions, the student goes through and answers those 10 questions, and then they get graded. But are there other ways we can use the technology? And one of the things that we've done and we have as an example is the escape room that you can actually try from the exhibit hall from our booth. And the idea of the escape room is that these are questions that are asked in different ways. The students can work together as a group or individually to solve these problems, to go through a series of problems and get to the end. So they're not sort of your basic plug and play type questions. They're questions that really get at their understanding. The other thing that you can do with technology is you have the ability to do sort of data and analysis type questions. This is probably more applicable in a science course where students may be taking measurements and then trying to do some analysis after the fact. Again, in the last year and a half, this has been something that has been done online, but traditionally would have been done, say, in a lab, and then the students would report on it. So how can we use some of the features of technology to ask those types of questions and be able to get the students to still do some of that analysis that they would have traditionally? And then finally, looking at written or oral assessments in STEM. Here, again, Möbius has an essay question type, so you can ask students to explain or talk about how they got to a solution or what their thoughts were on something or their analysis. And then you can manually read that and give them a grade. One of the other things that we've seen in the last sort of year and a half is that a number of instructors have also added an oral assessment part, so that they're actually talking to the student to get a better sense of what they understand. So then if the student answers something, they can ask them a question on it and really understand sort of how deep is their understanding of the topic. So what I'd like to do now is I'm going to go into a demonstration of some examples and just talk a little bit about some examples. So this is inside of Möbius, and I've created what we call a lesson. So a lesson is just a compilation of material, can be text, can be videos, can be interactive elements. In this case, I've just put a whole bunch of questions together so that we can talk about sort of the moving up the Bloom's taxonomy, moving up the pyramid. So this question would be your typical remember question, your factual type questions. So two triangles are what, if any of the following criteria are true. So here, hoping that the student remembers the word congruent. if all three sides are equal. So here the student can type something in, or they can use a drop-down list, or they can type something in. So your basic sort of questions. With all of the questions here that I've created, you have the ability to click and see how did you do in that particular question. If we now move into sort of the knowledge and comprehension, so this was sort of a very factual type question, but you could also go to a question which again is sort of knowledge and comprehension. You've shown the students how to factor an expression, and now you want to know, can they do that? So now you have the ability to create a question which is just that, factor this particular expression. So as the students put in their answer here, x minus 3 times x minus 2, and again, they can click on how did they do. All of these questions can be made algorithmic so that students can try more than once. So they can click again. This one I made as static, but you do have the ability to create algorithmic versions so that the student can practice as they go through these questions. But again, this is sort of at the lower level of Bloom's taxonomy, because you're looking at just, you've learned a procedure. Can you do that procedure? This is a question that a student would be able to plug and play into Google, factor this expression, and they would get an answer and be able to type it in. So what we want to move to are questions that are asked a little bit differently. If we move to the understanding side of things, so now here we're asking, which of the following is the graph of this derivative of negative x cubed plus 2x plus 1 with respect to x? So the student, in this case, it's multiple choice. They can scroll down, see the different options, and then select the right one. In this case, most instructors understand multiple choice. Students can game that a little bit, right? Students may be able to go, okay, well, if it's x cubed, it's going to be a quadratic, so that cancels out these two linear functions. So now I have 3. It has a negative. So now I'm down to these 2. And so they can sort of almost guess and really get down to just a couple of options that they then would use to decide on what the right answer is. So what if we ask that question a little bit differently? Here we have now graph the derivative of the following function. The student has a blank graph. So now they have to enter in what that expression is. So here, once they've figured out what it is, they can type in, they can click on the parabola, put in the vertex, and then put in one additional point. So here, and then they have the graph, and then that can be graded. So now it's not a question of, do they just type in an answer? Do they look through the multiple choice and determine which is the right one? But they actually have to think about what is it and do the graph themselves. If we look at the apply type of a question, so here again, what is the equation of the line that passes through 3, 9 with a slope of 2? So the students, this is again sort of a procedure question. Can you apply the knowledge that you have? So the student knows that the equation of a line is y equals mx plus b, y equals 2x, and then they just have to figure out what b is. They can substitute in that point and solve for b. And then again, they can check to see if they did it right. But now if we want to get up a little bit higher on Bloom's taxonomy, you can ask a question like this. Provide an equation of any line that passes through this point. So now the student isn't given a slope. They aren't given the slope point. They aren't given 2 points where they can calculate the slope. So they have to understand that in this case, because they're being asked for any line, it doesn't matter what that slope is. And so what they need to enter here is a linear function that goes through this point. So here they could type in y equals 6, or they could type in x equals 3, or they could put something like y equals 2x as an example. All of these would be graded as correct. So here, if the students checks, how did I do? They get told they're correct, but then down below there's also feedback. So it actually gives the student immediate feedback on what they've done and the solution to that particular problem. Here's an example where you can see the try another. So right now we had it going through the 0.36. If I select try another, I now have 515, 714. And so the student could try it a couple of times or as many times as they want to, but it's a different way of asking the question that gets a little bit higher on Bloom's taxonomy. And now when we look at, for example, the calculate and analyze question, here's a question where what we're getting the student to do is, again, this one is more of a science question, but they're measuring. So they're given something and they're measuring some value. So I'm just going to put in some values here. Then they're told, now what is the volume of the water plus the sample? So here they've put in some values. And then what is the volume of just the water by itself? So this was all measurement. So this is something where the students are either measuring some elements or doing some brief calculations. Now the second part of this question is the analysis part. So just like they would do in a lab, it's like, okay, so what is the volume of the sample? So here they're going to take the volume of the water plus the sample and subtract the volume of the water. And so now they go through and they do all of this calculation, and then they have to determine the density of the sample. They're given an equation that they would have known, and they can go through and do that calculation. Now these values, this calculation is all based on the measurements that they have done up above. So now even if they made a mistake in the measurement, as long as they can calculate the density appropriately, they can still get the marks. And then finally, they go through and they calculate what is the mean density as well as the standard deviation using the formulas that they know. And then looking at this information based on the density and of the sample and the weight of the sample, they're asked, now what is this unknown metal? So here the student has to actually look at what they've been provided, look at their periodic table and figure out what is the right metal that based on this sample that they've been given. Now this sample up here, the students could either measure that themselves or they could be given that and then still asked to do the analysis. But it just allows you to go beyond just straight calculation, being able to put a lot of the things that they've been working on in class together and then do some analysis on it. The last couple of questions that I have here, the last two questions that I have here are from the escape room. So I'm going to give you a little bit of a sneak peek if you haven't tried the escape room. And the reason that I've included them is because, again, they allow you to get a little bit higher on that Bloom's taxonomy. So, and there's some great examples of questions. So this particular question, a machine has a screen which displays this piecewise function, where the values of the parameters A, B, C, and D are controlled by a dial below the screen. And the dials can be set to integer values. So now there's a sticky note attached to the machine that says, create a continuous path to activate. And you're asked, what values do you set the dials to? So now it's not just a simple question of solve an equation given to a particular value. It's not, can you do this procedure that you know, but it's, do you understand? If I give you a piecewise function, what does it mean for that to be continuous? And so here we have from x is less than or equal to -2, the value is 3. So then at -3, this second part of the piecewise function, what do I need that to be in order for it to be continuous? I need it to equal 3. So now I can set up an equation and solve to get to there. But it's not a simple question. It's one that requires an understanding of what does it mean as a piecewise function? How is that calculated? As well as what does it mean for it to be continuous? And then they have to do the calculations to solve. So this is a really great example of just that higher order thinking that we want to get students involved in, especially in our math classrooms. And this last one, is more on the examine and assess. So this question, it'll just take a minute because we have a number of graphs here, but this question really makes the student think about what is it that they're looking at. So a storage closet contains something that you need, but the entry is controlled by a keypad. On the keypad, someone has written with a marker, code equals ABCD, but the keypad is actually numeric. So next to the keypad, there is a sheet showing these 2 rows of graphs. The first row of graphs are labeled A to D, and then the second row are 1 to 4. So now these graphs are related in some way, but how? So a student who really is struggling with the math concepts in a calculus class of derivative, what does it look like, will look at this and really have a hard time understanding it. But now a student who maybe is says, okay, well, I understand, you know, when I take a derivative, what does it mean? What does the second derivative mean? Like, I got this. They can look at this and say, okay, so here we have, you know, when we look at these graphs, it's below 0 at a certain point. It's above 0 at a certain point. It's increasing, it's decreasing. And it's really just making the students really think about what does it mean for those different areas where it's increasing, where it's decreasing, where there's critical points, where it's above 0, less than 0. And how could that possibly relate to these other graphs? We're now at sort of the top end of Bloom's taxonomy, because this is something that, again, is not something that they will know just because they took a derivative. It's something that they will know because they've understood the concepts that they've been learning. And these are the types of questions, obviously, you know, students will see these as much harder questions. So you have to, you know, put some of the sort of more general questions, more basic questions, traditional questions within your assignments and your lessons. But you can now, using technology and using a platform like Möbius, really get to this higher order thinking and ask questions that have some meaning and that really are pulling out the important pieces that you want your students to know. So these last two are actually from the escape room. And so obviously I'm not going to tell you the answers, but it gives you a little bit of an insight into the questions that are in the escape room. And if you haven't had a chance to go in, please stop by our booth and take a look at the escape room. If you get to the end, then you can go in, you know, put your name in for a draw for a $300 Amazon gift card. At this point, I'm going to sort of stop sharing and I'm going to pause and ask if there are any particular questions. All right, so I don't see any questions. So this is the end of the session today. I hope you enjoyed the session. Thank you very much for your time today, and I hope you have a great rest of the event.